All right, guys, we'll go ahead and get to it here. This is our last new lesson from chapter 2. And if you keep track of the numbering, you might notice we went from 2.4 to 2.6. So basically, I'm going to give you kind of what 2.5 would have looked like in this first example. You don't really need to know how to solve these algebraically, but I'm going to show it anyways. If you're interested in really learning it, I'll reteach it on Tuesday in Flex. But really, the part of the notes that the big takeaway needs to be page 2, which looks like this, and page 3, which looks like that. We'll go through those quicker because by hand takes longer, but you don't really need to know how to solve them by hand. And by them, I mean 3-variable systems. Our learning target says I can solve 3-variable system let's try that one more time. I can solve for a 3-variable system of equations with technology. So that technology is going to be Desmos. I also have old notes kind of posted and stuff if you're interested in learning how to use your graphing calculator. It's a little bit more of a process, but Desmos should keep it pretty easy. Anyways, we're going to start with a secondary skill here, which would be how could I solve this algebraically, okay? So there are a couple strategies you could use. You could use matrices, which we'll get into those in a minute, or you could solve these algebraically, which is how I'm going to show it. So what you would do here, and again, you may or may not want to even write this out, okay, because you don't necessarily need to know how to do this. You could actually go back and do this one with Desmos. So if you didn't have Desmos, though, this is what you would do, okay? Step 1 would be try to eliminate the same variable from 2 equations and give yourself a 2-variable system. Okay, so like if we look at x's here, my coefficients are -5, -3, and 1, so that could be pretty easy to work with potentially. So I'm going to try to eliminate x from 2 equations, right? So if I added some version of these two together to make that happen, what I would do is maybe take row 2, -3x plus 7y minus 10z equals -12, plus 3 times row 3. Then that would cancel out the x's. So x minus 2y plus 3z equals -3. Okay. Again, keep in mind, I'm going to work through these pretty quick because you don't necessarily need to know how to do it this way. Okay. So that would give me -3x plus 3x is 0. 7y minus 6y would be plus 1y. -10z plus 9z would be -1z. And -12 plus -9 would be -21. Okay. So I have a y and z only equation there. Okay. And then I try to create one more of those. Okay. So to do that, I'm going to use row 3 and row 1. So my strategy there is going to be to add 5 of row 3 to row 1. Okay. So -5x plus 12y minus 18z is 10. And then 5 of row 3. So 5 times x minus 2y plus 3z equals -3. All right, so again, that's going to give me 0x. Then I'll have 12y minus 10y would be 2y. -18z plus 15z would be minus 3z. And then on the other side, 10 plus -15 would be -5. Okay, so now basically I've whittled it down to where I have two variable equations, which now we're more familiar with that. So then we go into phase 2, which would be solve for y and z. Okay. So I have my y minus z equals -21 equation. I have my 2y minus 3z equals -5 equation. Okay, so if I want to eliminate y, I could multiply by -2 up top, add them together. So -2y plus 2y is 0. Positive 2z plus negative 3z is negative 1z. Then I'd have 42 plus negative 5. That'd be 37. So negative z equals 37 gets me z equals negative 37. So finally, after all that, I have one of the parts of my solution. Okay. Then we use z to find y. So I'm going to sub in right there. So we could go y minus negative 37 equals negative 21. Probably easier to think of that as y plus 37. So y is going to equal whatever negative 21 minus 37 is. So that'd be negative 5, 8. So we have z, we have y. Step 3, we use those two variables to find the third. So now we go back to an original equation from our system. To me, this one maybe looks simplest, so I'll use that one. And I'm going to sub negative 37 for z, negative 58 for y. So last kind of phase here is find that third variable. So we'd go x minus 2 times negative 58 plus 3 times negative 37 equals negative 3. Okay, if we simplify that right side, negative 2 times negative 58 is plus 116. 3 times negative 37 would be minus 111. Add your like terms. We really just have x plus 5 equals negative 3. And finally, x equals negative 8. So altogether then, we have x is negative 8, y is negative 58, z is negative 37. Another way you could write that is as an ordered triple is acceptable. So x, and then y, and then z. So you could also write that as negative 8, comma, negative 58, negative 37. So that was a long little spiel about something you don't necessarily need to know how to do. But this is all the work. I'm going to show you how, how we can skip it using Desmos. Okay. So if you'll flip over. If you forget anything today, this is a pretty nice, easy thing to follow. All right. But basically, how we can use Desmos to solve a similar 3-variable system. Okay. So one thing we want to be able to do to start is convert to this thing called a matrix. So pretty simple. You basically just use the numbers, not the variables, the coefficients. Okay. So like everything in here is already in standard form. So like you just go, you just go across the top there to make your row 1. So we'd say row 1 is 5, 2, 1, 5. 5 from 5x, 2 from 2y, 1 from 1z, 5 from 5, right? You just leave little spaces between each entry, okay? So row 2 then would be 3, negative 3, negative 3, 9. And row 3 would be 1, 2, 4, 6. All right, so we'll see what to do that with that in just a second. I had realized that I cut something that's on your test out of the notes accidentally, so let's make a little addition right here. Just kind of understanding the ins and outs of a matrix. This is pretty simple, I think, but on the study guide and test, it's going to give you like maybe a matrix, something like this, and it'll just say name the element, just write a, make up a couple numbers. Let's say 2, 3 equals what? So that's not going to make any sense if you don't know what that means. So let me tell you what that means. All right. The first number is your row number. Okay. So this means row 2. I'm going to put R2. and then column 3. So rows go horizontally, columns go vertically, right? So row 2 would be these guys right here. Column 3 would be these guys here. Row 2, column 3 is the intersection of those two. So that'd be -3. And that would just be your answer, right? We're not really doing any math. We're just naming an element. So just to make sure you get it, maybe you and your partner discuss what if I flip those around? What would A32 be? Just a number. Take about 5-10 seconds. I'll tell you what it is. All right, so that one, you should have been looking for row 3, column 2. So this guy right here. So it should have been 2. Does that make sense? Anybody have any questions? So not a whole lot to cover there. The big part, though, is what can Desmos do with that matrix? So you can see a clip here. So we enter it as a matrix, just like we did on paper. Then we convert to what we call reduced row echelon form. All you have to remember is RREF. You'll see that on Desmos. Okay? And then it'll give you one that looks like this. All right? That's what reduced row echelon form looks like. Lots of 1s and 0s to the left side. And then the right side, that right column, column 4, that's where your solutions are, right? So if you look underneath here, that means X is 2, Y is -4, Z is 3. So, literally, if I take this very literally, what this top row says is 1X plus 0Y plus 0Z equals 2. More simply, X equals 2, right? This one says Y equals -4, and this one says Z equals 3. Okay? Yes. We'll do it right now. That's a perfect segue. So the question was, how do we find that on Desmos? So let's go ahead and do example 3, 4, and 5 using Desmos together. And guys, we're going to go through this page a little bit quicker than when I did the first page, but this is the important page, right? Because you can use Desmos. You don't have to be able to solve them by hand, okay? Now, when you are writing your original matrix, that's part of showing your work. You want everything in standard form. So in this example, these terms are kind of jumbled up. So I would just go alphabetical order, okay? So I would think of this when I'm writing my matrix as -11x minus 4y, just kind of reordering my terms, equals 36. And then on the other one, we're going to have -10x minus 10y equals 20. So that just will make it look cleaner. Then we'll know column 1 are my x's, column 2 are my y's, column 3 are my constants. Okay, you just want to be constant there. All right, so as a matrix, what we're going to enter into Desmos here in a second, I'll show it on the screen, is this matrix right here. Row 1 is -11, -4, 36. Row 2, -10, -10, 20. Okay, so the way we find this matrix calculator should be kind of right out on your home screen. So let me navigate from here. So Desmos, home screen, just down here. All right, so there's your matrix calculator right there. We're going to start by entering a new matrix, and we're entering a 2 by 3 here. So we have 2 rows and 3 columns. Columns is always one bigger than rows. Okay, so then we just enter our numbers. -11, -4, 36, -10, -10, 20. Okay, just double check. It's easy to miskey something. Once you have it in, you feel good about all your entries, hit enter. And now we remember it's called RREF. So we hit RREF, we enter, this is called matrix A. So enter your A, And there it is. That's what an RREF matrix is going to look like. Those nice ones and zeros on the left, and then solutions in my right-hand column. So let's go ahead and copy that on our paper. Row 1 was 1, 0, -4. So 1, 0, -4. And row 2 was 0, 1, 2. Everybody with me on that? Did I get that right? 1, 0, -4, 0, 1, 2. Yes, Gentry. We'll do that in just a second. All right, so let's interpret what we have here. This is kind of showing our work. So what's our final answer then? What would we say the solution to this system is? Anybody? Nobody? This top row says x equals -4, and the bottom row says y equals 2. Okay, so these lines cross at -4, 2. Okay, -4, 2. Does that make sense? Anybody have any questions? Yes. Yeah, I'm going to show it just right now. Yeah. All right. So let's go ahead and set up to do another one here. Okay. Everything's already nice and in standard form, X, Y, Z. So let's go ahead and write out our original matrix. So we go 1, -6, 4, -12. 1, 1, -4, +12. 2, 2, 5, -15. All right, so we're going to now convert to RREF form. Okay, so I'm going to show this on Desmos, but just getting ahead a little bit. That should say something like 1, 0, 0, blank. 0, 1, 0, blank. We'll get the blanks from Desmos. But that's what RREF in general is going to look like. X equals Y equals Z equals. Here's the Desmos part. Okay, so you can either hit enter again to do a new matrix, or I like to just clear it out. There's this clear. So if we hit clear a couple times, that'll give us a blank screen. Everybody with me on that? Okay. Then we want to go new matrix, and this time it's a 3 by 4. Okay. So then we just enter our original matrix here. I'll go ahead and do that. Again, once you get it all in, just double check. It's easy to miss a negative or miskey something. A lot of times when you do, though, your solutions will look kind of janky, right? So that'll be a red flag. Maybe go double check my entries. All right, so then we RREF matrix A. And there we get that last row. It says a 0, 0, -3. Okay, so can anybody interpret the top row for me? What's the top row tell me? Gentry? X equals 0. That's exactly right. So the top row means X equals 0. What about row 3? What's row 3 tell me? Yes? Ready? Z equals -3, right? And Y equals 0 is row 2. Okay? So that's how you interpret that. So again, my solutions, you can just list those as an ordered triple. 0, 0, -3. With me? And again, just like, if you're more of an algebraic person, you can take those solutions and, plug them in, right? If I plug in 0 and 0 and -3, does it fit that solution, or does it fit that equation? And yes, it will. Corey B? So yeah, good question. So Corey B is saying, how do you want us to show our work on the test? And I would say just like this, right? So an original matrix, an RREF matrix, and a solution, right? And again, if you want to get crazy, you have the option of, showing it by hand, but you do not have to, because yes, you can use Desmos, okay? And again, if you're interested in learning how to do this on your graphing calculator, I can show you. Desmos is a lot easier though. Okay, so let's finish up with this last one. I'm gonna kind of type it in quietly, and we'll get back together in about a minute or two. Okay, so if you haven't started this one yet, go ahead and let's look at it real quick. All right, so I went through that pretty quickly, but hopefully you're able to follow along. And what we get is a little bit different. Okay, what you get at the end is a little bit different. We have multiple ones in the Y row, and we don't have a one where we should in the Z row, right? In the Z row. Sorry, that came out weird. I don't know what happened there. But yeah, so let's copy this down, say what it means, and we'll be done with it. Okay, so original matrix was 5, 5, 5, -20. Row 2, 4, 3, 3, -6. Row 3, -4, 3, 3, 9. RREF matrix was 1, 0, 0, 0. So that row looks fine. That row says x equals 0. The next row says 0, 1, 1, 0. So what that row says is y plus z equals 0. So that's a little different, right? That's not like what we're normally after. And then the row underneath says nothing equals 1. All right, so this row right here says 0 equals 1. Anybody remember what that means? It's a special case. Would that be IMS or no solution? No solution. 0 does not equal 1, so this is what a no solution looks like. We're going to have to cover this a little more in depth on Tuesday. I'll show you the IMS thing, but that's a little preview. Okay. Keep in mind as you're working through this, Alex, your Alex set goes with day 1 and day 2. So if you see a word problem, you might be able to figure it out, and that's fine. But we're going to cover it Tuesday as well. You will not get a new Alex for Tuesday's part of the notes. All right, so hopefully this helps. I'll go ahead and post your Alex, and let me know how I can help you today, people.